these names? I mean, we can connect to the servers by using the IP addresses, and that's all we need. We can establish TCP connection with the server, and the TCP needs the IP address in order to establish connection, and then we can obtain web pages, files, whatever else we need from these servers. Why are we trying to create names such as google.com or moodle.edu or something else, or uncc.edu? Or
I think it's first is like easy to remember. Second, also like if they like the server Google, if they want to like change the IP address, but if they change the IP address, but people know that like that they're like google.com, but it doesn't matter they change. They just like reconfigure it.
okay, so one thing is that what if they change the IP address? We will no longer know the IP address, so we cannot connect to them, right? What if we can't even remember this IP address? I mean, can you remember Google's IP address, and every time you have to type it in?
but Google has like so
They
many
did
things.
make it easy. So.
It's all 8s. That's their IP address, all 8s.
Yeah, no, their DNS servers is all 8s.
Yeah.
And you get 1.4.4.
Yeah, those are DNS servers.
Yeah.
I
See,
am
they're
guessing right now.
From
Is it?
Google probably must have more than one IP address, right?
So people connect to Google, and I will type this. So Google comes up. So I don't really need to say google.com, right? So why are we creating these names then?
There's no HTTP server on that.
Okay, so one thing is that the humans cannot remember these things. Humans cannot remember IP addresses. So we try to make our life easier and create some user-friendly names, such as google.com or uncc.edu. But now, when we create these user-friendly names, the TCP now doesn't understand these names because TCP needs the IP address to establish a connection. So now we have to create tables to map the names to the corresponding IP addresses in order for the network connections to work. And so the domain name system allows us to do that. So it will keep like a huge table of domain name mapped to the corresponding address. And so whenever the browser wants to connect to google.com and we say google.com, it needs to first contact a DNS server to obtain the IP address of google.com before it can connect to it.
Does it always like connect to the end server?
Always. If it doesn't, it's not going to work.
What about cache?
That's part of your homework. We're gonna do an exercise with that. So basically, if the DNS doesn't work, I mean, if it doesn't connect, if the browser cannot connect to DNS, it will be unable to obtain the IP address of Google, and it will be unable to establish TCP connection unless we just said connect to the IP address, which I just did that earlier. I could say http://204.85.30.83, and then it will open the page. But if I say google.com, it has to contact first DNS to obtain the IP address. So the DNS, the domain name system, allows us to keep names, a table with names and the corresponding IP addresses that they map to. So we would use some sort of readable names. Such as, for example, www.computerscience.washington.edu, for example. In the beginning, these were just recorded in a text file called hosts. You might still have some of these host files on your computers if you search for them. On your laptops. In the beginning, they were called hosts, and this file contained all the mappings between the name and the IP address. Now, after the internet has grown huge, it was impossible to keep all of these names and the addresses into a single file. So we went to a hierarchical system, distributed hierarchical system, which looks like that. So the DNS is a distributed hierarchical domain-based naming scheme. Why is it distributed now? Why can't we have one huge server in the world that will hold all these things for us? But we want to have it distributed among multiple machines.
First of all, maybe like if that's just down, maybe first down one service and the after that. Also, like if you want to change that case, you just need one more server case to like just to change the other.
Yeah, exactly. So what if the server was compromised? So let's say some hacker killed the DNS server, and so all of a sudden nobody will be able to convert names, domain names into IP addresses. So that's not a good idea. So we decided to break it into many servers and create a sort of a distributed system so that we don't have a centralized point of failure. So if we look at this, it manages names and maps the names to IP addresses. So if we look at this as a tree, we have 250 top-level domains, such as .com, .gov, .edu, .org, .net, and so on. These are called the generic domains, and then we have country domains, such as US for United States, NL for Netherlands, JP for Japan, and so on. Yes?
I had a question about how it's distributed. Is it faster because it's distributed as well? Because, I mean, is it easier to access a DNS server if you have one closer to you? Does it know how to choose the closest one?
Oh yeah,
Okay.
yeah, absolutely. It's of course much faster to access DNS server which is close to us than some DNS server which is in Japan. But also the DNS server itself would hold much smaller tables only for local or nearby addresses. So it's divided into zones like that.
So like how like does computer to find DNS server? Whenever we send it, just automatically goes to ISP. From the ISP, does it automatically finds the nearest one? Or
So when we get the IP address from the internet service provider, it will provide us with also the address of the DNS server. So basically, if we look at the network configuration, we will see our IP address that we got, and we will see the address of the DNS server. So if our browser is trying to contact google.com, first it has to contact this server to figure out what is the address of google.com.
did we get this IP address from the ISP or?
Yes, from the ISP.
It's like does it update often? Maybe like DNS servers could be changed, right? Because like maybe I use the laptop and go to another place. I need to change also my DNS server IP address.
Correct. Every time that we connect our laptop to a new network, you will get a new IP address, right? And the DNS server and everything else with it.
So can we run like DNS server and local in the lab?
Can we run DNS
Server in local network?
Okay, you can start your own DNS server on your own laptop.
It means like when they're trying to find some websites, are they going to connect to my websites? From my DNS server
Not
to get that
unless
IP
you
address?
configure them to do that.
How do we update like laptop or like other computers DNS server IP address? That
The
they just
internet service provider will do that automatically. So remember that it assigns an IP address dynamically through this protocol, dynamic host configuration. So it's going to do the configurations for the host, which is our personal laptop, is the host. And so it's going to configure its IP address, its DNS server, its default router, all of these things.
But can I like tell another computer, hey, you need to update your address. Hey, you need to update your address, something like that. Then I just update it with my local DNS server IP address.
Absolutely, that's what hackers do.
They will connect to mine, right? Then I will just give some
That's called
fake IP
DNS
address.
spoofing. So they will go and change the DNS address of somebody. And instead of going to the correct DNS server to obtain the correct IP address of google.com, they're gonna go to a spoofed DNS server and obtain an incorrect address of google.com and connect to some hacker's website instead, thinking that they connected to Google. That's been done. That's completely possible.
How
So,
easy is
yes, you can do that. You can actually do that. I don't know how easy it is. If it's our laptop, it's easy. You go and change the address. But if somebody else's property laptop, then you're gonna have to break into their system somehow before you can change that. So, well, you can change any of these addresses in the network configuration of the computer. So let's look at the DNS. So it has the 250 top-level domains, which are the generic domains, either or country domains, and then there are a bunch of subdomains underneath. For example, under edu, we said computerscience.washington.edu. So under edu, we have a subdomain called Washington. So that's for Washington University. Within the Washington University, we have a computer science department. So that's a third level domain. And we can have a fourth level domain, such as robots, computer science.washington.edu, and so on. But once we are assigned the domain Washington edu, now this domain is under our control, and we can create subdomains underneath. But the top level domain are controlled by an international organization called ICANN. So they are controlled by ICANN. because similar to IP addresses, we want to have unique domain names. So this is international corporation for assigned names and numbers. And so this international corporation will manage the top level domains. So for example, if we want to request the name google.com, can we do that? Yes. But are they going to give it to us? Probably not, because the ICANN will go and say, the google.com is already taken by somebody else, so we cannot give it to you, so think of another name they want to use. Because we want to have unique DNS name correspond to a unique IP address. If we have two of the same DNS names assigned to different companies, then that would create some confusion. So the DNS name is unique, and it's assigned to precisely one unique IP address. So let's look at what types there are. COM is for commercial, PD is for education. Then we have government, international organizations, military, network providers, and a bunch of others.